Okay, well, hello. My name is Lee Stivers, and I am an extension educator with Penn State Extension. I'm based out of Washington County, which is in the southwest corner of the state of Pennsylvania, and I work with greenhouse and other horticultural crop growers in the southwestern region of Pennsylvania. Today, I am going to be speaking on the topic of mixing and measuring small amounts of PGRs and pesticides. So one of the key steps in making effective applications of crop growth regulators and pesticides is measuring and mixing the product accurately. So if a crop growth regulator or a pesticide product is applied at a rate or a concentration that's either too high or too low, the results can be really disappointing and sometimes quite costly. So in greenhouses, we often only need to mix up a small amount of product for an application, but mixing and measuring small amounts accurately can be kind of tricky. So I'm going to talk about best practices for measuring and mixing small amounts of products, both liquid and dry formulations of products, and then I'm going to delve into some rate-based math, which is what helps you do the calculations for your mixes correctly. So specifically, I'm going to talk about measuring and mixing accurately, how to accurately measure products and doing the calculations accurately as well. And you may actually be pretty comfortable with mixing and measuring products, and you may be pretty comfortable with the calculations behind doing this, or maybe you're not. And a question is, are your workers or your coworkers comfortable with this stuff too? As I mentioned before, it's pretty important to get it right, or you can do quite a lot of damage and costly damage to your crop. So let's start by talking about measuring liquids. Liquid measuring devices, that not all measuring devices are the same and not all of them are accurate. So looking at them from a standpoint of accuracy is a good place to start. How do you check for accuracy? Well, for liquid measuring devices that are measuring a little larger amounts of liquids, you want to buy an accurate graduated cylinder and then use it to check the accuracy of your measuring device. You want to look for liquid measuring containers with pour spouts and handles, and you also want to make sure that the gradations on them are easy to read and don't get rubbed off or over time. You might consider using taller and narrower measuring containers. This helps make them more accurate when there's more space between the gradations on those on the marks on the sides. So a little taller and narrower measuring containers tend to be more accurate. But for really small amounts, you should consider using syringes. Medical syringes, veterinary syringes are available for purchase in all kinds of different sizes. Of course, you can't go purchasing the needles along with them, but without the needles, you can certainly purchase them without any kind of license or anything. And these are really handy tools to have for measuring small amounts of liquids. And these come in a variety of sizes. I think this one looks like it's a 60 milliliter or cc's. Just remember that milliliter and cc is the same amount of volume. It's the same unit. This one is, I think, a 10 milliliter. We've got a 5 milliliter, and even syringes that will measure in portions of 1 milliliter. So syringes are really helpful in measuring small amounts of products. So with our English system of measurements, we can get confused about some of our units, and specifically about ounces. And we have to remember that liquid and dry ounces are not the same thing. A liquid ounce is a volume measurement, in contrast to a dry ounce, which is a measure of weight. And some of the products we work with are liquids, and some of them are dry flowables or dry formulations. And we talk about ounces of one, ounces of another, but we have to be aware and remember if we're talking about liquid ounces or dry ounces. One fluid ounce is always going to be the same volume regardless of the liquid, but one dry ounce can be a different volume based on the bulk density and particle size of the formulation. So let's take a look at this, what I mean. So here are 4 different liquids. Let's say they're 2 ounces, 2 fluid ounces of each of these liquids. It looks like we've got water, maybe some dish detergent, some purple Gatorade, and some mouthwash. These could be pesticide formulations, but they're probably not for this picture. But the point is that this 2 ounces, that's all the same, regardless of what the liquid is, it's all 2 ounces. They're all the same volume. Now, if we look at dry materials, then there's a contrast to ounces as a unit of weight. Here we have 4 ounces by weight of salt. Here's 4 ounces of baking powder, 4 of chili powder, 4 of brown sugar, 4 of flour, and 4 of oatmeal. All of these materials have different density, different particle size, and you can see that they take up very different volumes, even though they're all 4 ounces by weight. So if you're trying to measure out a dry flowable product in ounces by weight, you can't do that easily with a device that measures liquids unless you have some kind of extra information. You might have a conversion chart that tells you, something, this just is some fungicides, different formulations that give you teaspoons per gallon of how much you need to mix up. But these charts become obsolete. The pesticide labels change, the formulations change. So this isn't a very good way of doing this. Some products come with their own measuring tubes to get around this problem. So you've got a dry product, and the manufacturer just attaches a tube with it so that you can measure out essentially in volume how much you need of this dry flowable by weight. And again, you have to have the specific tube for each product. So you can see a problem there. The tubes get lost, you use the wrong tube, and suddenly you're using the wrong amount when you're mixing a product. So really the very best way to measure dry formulations, the most accurate and consistent way is to measure dry flowables is to weigh them on a scale. Scales used to be something that were quite expensive, but these days with electronics as cheap as they are, it's really quite easy to buy a scale that weighs amounts as small as 0.01 ounce or 1 gram for something like $100 to $200. So if you're doing this kind of work, it's really a worthwhile tool to have to measure out small amounts of dry formulations. All right, so I've talked about measuring liquids and dry materials. Let's do a little math. So applying the proper amount of a pesticide or a product like a PGR requires that first you know how much volume per unit of area that you're applying at a given speed and pressure, and we call that sprayer calibration. And second, that you mix up the right amount of pesticide product plus water in your tank, and that is the concentration of the mix. So the calculations for these both involve rates. So I want to talk a little bit about rates and rate-based math. So a rate is one unit of measure per another unit of measure, and we use them all the time in agriculture and horticulture. So a rate is some number of one unit of measure over some number of another unit of measure. For example, 3.2 gallons per acre is a rate. So we've got 3.2 gallons, that's a liquid unit of measure, per 1 acre, which is an area unit of measure. Or another one might be 7 fluid ounces per 1,000 square feet is another rate. So let's talk a little bit about the math of when we're using rates. A rate is kind of like a fraction. In a way, it's like a fraction. You can multiply rates and conversions just like you do fractions. So we're going to harken back to our primary school days when we're learning how to multiply fractions. So 1/2 times 3/4. Remember, you multiply the top numbers, the numerators. 1 times 3 is the number for the numerator, and the denominators. 2 times 4 is 8 in the denominator on the bottom. So you multiply rates and conversions just like fractions. But rates aren't always like fractions. One of the things that you can do with a rate is flip them upside down, invert them, to suit your needs when you're doing calculations. So 3.2 gallons per acre is the same as 1 acre per 3.2 gallons when you're doing the rate-based math. But we of course know that that is not true with fractions. 1/2 is not the same as 2/1, and if it was, I guess we would all be as rich as the folks who make Bitcoin. But that's not the way it works. Now, we use concentrations a lot in working with greenhouse products. Concentrations are a kind of rate. They're rates in volume to volume. So a lot of product labels specify application rates as concentrations. So concentrations are rates that have a unit of volume measure in the top number and a unit of volume measure in the bottom number. So for example, a 2% solution, which is a concentration, is the same as 2 fluid ounces per 100 fluid ounces of water. Sometimes these units are the same, fluid ounces to fluid ounces. Sometimes they're not for practical purposes, and we'll look at that in just a second. Often when we are working with concentrations, we are working with either percents or parts per million. And a percent is very simply 1 out of 100, or 1 per 100. Parts per million, just exactly what it says, is 1 out of 1 million parts, or just to put that in that same sort of rate visual, 1 per 1 million. So those are the typical concentration units that we are working in. So concentrations are volume to volume rates, but for practical purposes they aren't always the exact same unit, ounces to ounces or gallons to gallons. And that's because we're usually mixing up a small amount of product into a much larger volume of water. So it's often easier to work with the product in fluid ounces or in milliliters and the water in gallons. So you can do the math to figure out how much to mix up specific volumes of specific concentrations, but that information is usually right on the label in an easy-to-use form for products that we're working with in the form of dilution tables. So here's an example of a PGR. This is a very well-known bonsai with 0.4% the active ingredient paclobutrazol. And right there on the label is how to mix it. If whatever part per million concentration you're looking to mix up, you just read it off the table and it tells you how to dilute this, whether you want to measure out fluid ounces per gallon or milliliters, and here they're just noting that milliliters and cc's, cubic centimeters, are the same thing. So milliliters per gallon. So if we look at this bonsai, which is 0.4% paclobutrazol, and we compare that to a product in contrast, Piccolo, which is 10xc or 10 times concentrated, this is 4% the active ingredient paclobutrazol. And for this dilution table, again, it's giving you the parts per million that desired of what part per million concentration of the active ingredient that you are wanting to mix up, and the milliliters of the product per gallon of water. And you see, because this is so concentrated, these smaller part per million amounts are really quite small, just fractions of a milliliter. So you probably would need a syringe to measure those out if you're just making a small amount. But you can see between these two products that are paclobutrazol based, you better make sure you know which one you're working with, since one of them is 10 times more concentrated. Pretty important to keep track of which one you're using when you're mixing up. And just pulling those numbers off to compare, if you're making a 20 part per million solution of paclobutrazol as bonsai, you're measuring out 19 milliliters of product per gallon of water. Now 19 is pretty close to 20. If you're doing this with if you're mixing up that same 20 part per million solution of Piccolo using the 10 times more concentrated, you're only using 2 milliliters of product per gallon. So again, pretty important to know which one, to keep track of which one you're working with. Now, interestingly, if you look at the drench volume guidelines for both products, of course, you see that you're ending up applying the same amount of active ingredient. You've just mixed up the concentration mix differently because of the two products. So if you look at pot diameter 4-inch pots, a drench volume of 2 fluid ounce per pot, here you've got, whether it's 1 part per million, 0.063, this is for bonsai, it's exactly the same for Piccolo because you've diluted it properly. You are applying the same amount of the active ingredient if you've diluted it properly. So let's move to a rate-based math example and look at this from a pesticide application example. And I'll get a little bit more into the math. So here's an example where let's say you want to apply liquid pesticide to a landscape bed, and the labeled rate is 12 ounces per acre. The bed measures 160 feet square, and your sprayer applies 2 gallons per 1,000 feet square. So how many ounces of pesticide do you need to add to your sprayer? First question you want to ask yourself is, what is the unit of measure of the thing I'm trying to figure out? That will help you set up your math. How much pesticide are you going to put in your sprayer? How much pesticide do you need to apply? We already know it's in ounces that you liquid ounces that you're looking for. So first we need a conversion factor. We need to convert that acre rate into something with square feet. So we're going to pull up that conversion factor, and now we're going to multiply these numbers together, but we're going to do it in a way that cancels units so that we get to the ounces that we're looking for. So our rate is 12 ounces per acre. We know that 1 acre per 43,560 square feet, our acres cancel out if we multiply this way. And it's 160 square feet is what we are applying this pesticide to. And now we have our square feet canceling out as well. So we have the unit that we want, which is ounces. So we'll clean that up a little bit, pull out those units that we've canceled out. We've still got the ounces unit. We do the math, multiplying the numerators, 12 times 1 times 160 divided by 43,560 to get our answer, 0.044 ounces. That's how much pesticide we're going to need. All right, that's a pretty tough thing to measure, 0.044 ounces. So let's convert that into milliliters because we know we can measure that with a small syringe. So we need another conversion factor, 1 ounce being 29.6 milliliters. So we're going to set up the same kind of math problem, 0.044 ounces. We're going to multiply that by the conversion factor in this way so that we can cancel the ounces on the top, ounces on the bottom, and get this in milliliters, which is what we want. So we know that it's 1.3 milliliters is what we need to measure, and we can measure that. So how much water do I need in the sprayer? We can use the same kind of math to figure that out. So we know we're back to 160 square feet, 2 gallons per 1,000 square feet. Our square feet units cancel out and gives us gallons. All right, I don't really want to measure 0.32 gallons. I want to measure this in ounces. So I'm going to use this conversion factor of 128 ounces per gallon. My gallons cancel out by multiplying this way, and I get my answer. I need 41 ounces of water for that small application. You can use the same kind of math approach in calculating a backpack sprayer. We'll do this real quickly. So to calculate a backpack sprayer, how much water am I going to apply per a given area? Let's call it 1,000 square feet. So at a given speed and pressure, you want to fill the tank to a known level with water, spray out that given area. So 50 by 20 would be a convenient way of getting 1,000 feet squared, and then measure the amount of water required to bring the level back to the original level. So if it takes, let's say it takes 80 ounces of water to adequately cover that 1,000 square feet, that's your rate there. But let's convert this into something that we can use a little better. Let's convert it into gallons. So we're going to multiply this by our conversion factor of 1 gallon and 128 ounces so that we get rid of the ounces. They cancel out top and bottom, and we get the units that we want, 0.65 gallons per 1,000 square feet. So in summary, measuring small amounts, just remember that liquid ounces and dry ounces are not the same thing. Measure liquids accurately with narrow measuring containers or plastic syringes for smaller amounts. And dry formulations are best measured using a digital scale. If you're attacking one of these math problems, here's what I would recommend. For concentrations, just use the dilution tables provided on the product label whenever you can. That's just the easiest way to do it. For others, write down what you know in rates, the application rates, the area, the tank size, and include the units of measure in each of these pieces of information you have, and write it down in fraction form, in rate form. Define in units what it is you're trying to calculate. Do I want dry ounces? Do I want fluid ounces? Do I want gallons per acre? What is it that I'm looking for as an answer? And then go from what you know to what you're trying to calculate by canceling and converting units. And I appreciate the opportunity to do this webinar for you today. And we will just bring it to questions.